Now, today we have a very simple challenge on the board. But before we go into today's challenge, if you are new to this channel, kindly subscribe and turn on the bell notification button so that you get notified whenever we drop answer video like the one you're about to watch right now. So let's go into today's challenge. So the question says x equal to x to the power of 2 plus 6x to the power of 1 all over 2. All right, so we take down our solution. So from here, we are looking for the value of x, the possible value of x. So from here, we take down our question. It says here x equal to x to the power of 2 plus 6x to the power of 1 all over 2. Then, if you look at this carefully, we are having a radical here. Okay, so let's bring in another alphabet to represent this expression here, to represent our x, taking into consideration the smallest value of x. So if we bring in here, say, if we said let y be equal to x to the power of 1 all over 2. Okay, then if we want to look for x here, because we are having x to the power of 1 all over 2 here, and we're also having x to the power of 1, x to the power of 2. So let's bring x to the power of 1 and power of 2 from this relationship here now. So if we square both sides of this equation, then automatically we are going to have here y to the power of 2 equal to x. Okay, then if we are to take the square of x again, it will take this to y to the power of 4. So here we're going to have here y to the power of 4 is equal to x squared. So we now have all the quantities, the power of x we have here now, we now have there here, represented by y here. So let's go ahead and substitute these values into our main equation. So if we substitute, this will give us, here we have x, and our x here is y squared. So we're going to have here y squared equal to, here we are having x to the power of 2, and x to the power of 2 is equivalent to y to the power of 4, then plus 6, and our x to the power of 1 all over 2 is equivalent to y. So we have here plus y here. Okay, now this is our expression. From this expression, look at what we're going to do here now. We collect our like terms. So if we collect our like terms, or if we rearrange, we are going to have here y to the power of 4 minus y to the power of 2, then plus 6y, or equal to 0. Okay, very simple here now. Now, this is your quartic equation, okay? So let's solve this. And if you check carefully, y is common here, y is common here, y is common here. So let's factorize y out. So if we factor y out, we're going to have something out like this. So we're going to have y bracket of y to the power of 3 minus y plus 6 close bracket, or equal to 0. Okay, now we are having y into the whole of this. Okay, if we use the zero product rule, this implies, automatically this will imply y equal to 0, or y to the power of 3 minus y plus 6 equal to 0. Okay, so we've gotten one value for our y. Mind you, we are looking for 4 values of y from this expression here. So we have got to 1. So how do we now get the 3 other values of y? So let's proceed from here. Let's proceed. Okay, so we take this other side of the equation now, which says y to the power of 3 minus y plus 6 equal to 0. Okay, now from this, if we watch carefully, uh, how do we solve this polynomial? Okay, this trinomial equation. We can employ the use of a trial by error method. So let's try the trial by error method. And if we go by that, we're going to have here f of minus 2. Okay, f of minus 2 will give us something good here. Okay, so this will give us here bracket minus 2 to the power of 3 minus bracket minus 2 plus 6. So this will automatically give us here minus 8 plus minus times minus plus 2 plus 6. And you discover that this will give us 0. Okay, so y plus 2 is one of the roots of this polynomial. So therefore, when I have this, now implies that y plus 2 equal to 0 is one of the roots. Okay, so now that we've gotten one of the roots now, from here, let's use this root to divide this trinomial equation to get the other two. So from here, let's use the long division method. If we use the long division method, we're going to have here we have y to the power of 3. Now, I'm going to introduce y to the power of 2 just to complete the circle. But in there, the coefficient is going to be 0. So if I put in here plus 0 y to the power of 2, then here we have minus our normal y, then plus 6, okay, to be divided by this, which is y plus 2. Okay, so the essence of introducing this is just to complete this circle so that during the subtraction will not be confused. Okay, we now use this to divide this. So if we use this to divide this, we're going to have here y to the power of 2 and use this to times this. This will give us y to the power of 3 there plus y to the power of 2 times plus 2 will give us plus 2y to the power of 2. We can now rule of this. Put this in bracket. We want to subtract this from this. So if you do that, this will go with this because plus y to the power of 3 minus y to the power of 3 will give us 0. There plus 0y to the power of 2 minus plus 2y to the power of 2. Automatically, this will give us minus 2y to the power of 2. Bring down this next term here, which is minus y. Okay, now we now go back to our divisor. So we use this again to divide this. So y into minus 2y squared, this will automatically give us here minus 2y. So from here, we use your minus 2y times your y. This will give us minus 2y squared. Then minus 2y times plus 2 will give us minus 4y. We put this in bracket also. Okay, then we want to subtract. Let's put in our minus sign there. So minus times minus automatically will give us plus. So minus 2y squared plus 2y squared. This and this will leave. So minus times minus again will give us plus. So minus y plus 4y. Here we're going to have here 3y. Bring down this 6 here now. So plus 6. Okay. So we use this to divide this. We'll be left with plus 3. So if we do this, 3 times 3y, 3 times y will give us here 3y. Then 3 times plus 2 will give us log 6. And if you put your minus sign into this, then automatically we're going to have here plus 3 minus 3 will give us 0, plus 6 minus 6 will give us 0. So at the point where we have 0, 0, we take our answer here and solve quadratically. So from here, let's proceed again. So our equation, we now have here y to the power of 2 minus 2y plus 3 equal to 0. So we can solve this quadratically now, okay, using formula method, okay, using formula method. We're going to have this to be our a. Let's bring out our a first. So we have a equal to 1, comma, b equal to minus 2, and c equal to plus 3. And the formula says y equal to minus b plus minus square root of b squared minus 4ac all over 2a. So let's go ahead and substitute the value of a, b, c into this formula. If we do this, this will give us something like this: minus bracket minus 2 close bracket plus minus square root of minus 2 all squared minus 4 times a is 1 times c is 3 all over 2 times 1. So quickly, this will give us plus 2 plus minus. Here, we're going to have this to be 4 minus, you're going to give us 12. Okay, all over 2. Okay, so here we have minus 12. So if we simplify this, this will automatically give us, okay, let's come to this other side. So let's still continue on this. We have here 2 plus minus the square root of minus 8 all over 2. Now recall the identity, okay? So the identity which says that our imaginary I is equivalent or equal to the square root of minus 1. And so we can split that from here, okay? If we do that, this will automatically give us here 2 plus minus I square root of 8. Okay. Now, all over 2. This is all over 2. Okay, so let's still continue again from here. Root 8 could be split into 4 times 2, which is equal to root 4 times root 2. And if you do that, this will give us 2 root 2. So we can replace that in here. So we're going to have here, now implies 2 plus minus 2i root 2. Okay, all over 2. So if we factor out 2 here, okay, so we're going to have here 2 bracket 1 plus minus I root 2 all over 2. You know, the 2 here will take care of the 2 in here. So we are now left with your 1 plus root I root 2. This is the value for your y. Okay, so we have y is equal to this. So we now go into our expression now. So what are the values of our y? So we have our y. So first value we have y equal to 0. The second one, y2 is equal to minus 2, and y3 equal to 1 plus I root 3, and y4 is equal to 1 minus I root 3. Root 2, please. Root 2. Okay. So how do we now get the value for our x? We go ahead and substitute these values into the equation which says let y, because if you recall we said recall that we said let y equal to x to the power of 1 all over 2. So wherever we see our y, we put in this value there. So for case 1, we have here, case 1, we have y 1 equal to 0. It now implies that our x will now be 0 equal to x to the power of 2. So if we take the square of both sides, automatically this will now give us x is equal to, which is our x1 equal to 0. So the second one, we have y2 equal to minus 2. Minus 2. Okay, there the value of our x will now give us minus 2, okay, equal to your x to the power of 1 all over 2. So if we square both sides, then this will take care of this. Therefore, our x2 is equal to, we're going to have here to be 4. Okay, we continue again. So from here, let's put y3 and y4 together. So we have here y3, we give us here we have 1 plus I root 2, okay, equal to x to the power of 1 all over 2. So if we square both sides, so our x3 will now give us here, bracket open, 1 plus I root 2 all squared. Then we do that for the last one. So y4 is equal to 1 minus I root 2, okay, which is equal to s to the power of 1 all over 2. And if we square both sides, this will give us here 1 minus I root 2, close bracket, all square. This is our x4. So therefore, our x4 is equals to bracket 1 minus I root 2 all squared. Okay, now from here we can bring out all our values. So we have here x1 equal to 0 and x2 equal to 4. We have 4, and x3 equal to, our x3 from here is 1 plus I root 2 all square, and our x4 equal to bracket 1 minus I root 2 all square. You can as well factor out or simplify this down, but let's draw the curtain here. So thanks for your time. Thanks for being there. Okay, this is Online Maths TV. If you've not subscribed, kindly subscribe. Okay, thank you and God bless you. See you till some other time. Bye.